Hello folks, we come to the miscellaneous exercise chapter 7. This is our part 2 video. Part 1 video we had seen in the previous case. There seems to be a problem over here, the problem number 3. Let's read the problem, let's see what it says. A committee of 7 has to be formed from 9 boys and 4 girls. So you are given 9 boys and 4 girls as it is indicated there. You have to form a committee of 7. And how many ways can this be done? If there are 3 cases, they ask us to find the answer in 3 cases. You have to form the committee. First case, when there is exactly 3 girls. You have to have a committee which has got exactly 3 girls. Second part, where they say there is at least 3 girls. And in the third part, they say there is at most 4 girls. So, this is how we have to find the answer in these several cases. Now, we have to find out the several subparts, answers to the several subparts and the combinations that we have to do. We know, we've been doing combination problems, that your overall choice is given to you 9 boys, 4 girls. Then depending on the subcases, you find out the number of boys that can be chosen, number of girls that can be selected, work done in M ways, work done in N ways, total number of doing the work is Mn. This is what it is going to be like. Problems like this is easy, where we have a single straightforward answer. But these are not like that. They will have several subcases and accordingly we'll have to do our work. Now, we'll in a nutshell see how it is. Then maybe we will describe and get the answers. So, when you have to get 3 girls, it's very clear. This is our first subpart. 3 girls, very clear, very brisk and very crisp. You have to get 3 girls means automatically you have to get 4 boys. Because you have to have 7 people. When you have 3 girls, automatically you have got 4 boys. So that selection is easy. In how many ways you can do it? 9 boys, 4 boys out of the 9 boys can be selected in 9C4 ways. And 3 girls out of the 4 girls can be selected in 4C3 ways. So that solves the problem for the first subpart. Now in the second subpart, they say that you should have at least 3 girls. At least means minimum. So that means minimum 3 girls means you can have, there are 2 cases. First case where you can have 3 girls and second case where you can have 4 girls, or you can have 5 girls, or you can have 6 girls, or you can have 7 girls. Like that you can have several cases. But our problem here is we have a stock of only 4 girls. So we have to stop at 4 girls. So luckily for us, we've got only 2 subparts here. Had there been more girls, you have to consider more cases. So these are the 2 cases. Out of which also this case we have already done. So cases where 3 girls are there, we have already done. So we have to only consider the case where we get 4 girls, then add up. That's how we get the answer over here. Now, again to go about doing this, 4 girls, you have to choose a committee of 7. If you have selected 4 girls, automatically you have selected 3 boys, isn't it? So in how many ways we can do it? The 4 girls out of the 4 people can be selected in 4C4 ways, and the 3 boys out of the 9 boys can be selected in 9C3 ways. That's how we finish the selections here. After we get the numbers, we just add it up and that will give us a total. And that is the answer for this subpart. Now this subpart, slightly complicated. At most 3 girls means maximum 3 girls. Maximum 3 girls means you can have no girl. You can have 1 girl, you can have 2 girls, you can have 3 girls. So the several cases that you have to consider here is 0 girls. Then you have to consider 1 girl. Then you can consider 2 girls. Then you also have to consider 3 girls. So logically if you see, you have to find out the answers for 1, 2, 3, 4. 4th of course we have it here. So that is there, but the other 3 you have to find out. So that's a routine way of doing. You find out all the 3, then add it up. That will give you the answer for this subpart. But technically what we do is, in cases, so when we carefully inspect, you will come to know that out of the cases for girls, all the cases have been covered here except for 4 girls. Right? 0 girl, 1 girl, 2 girl, 3 girl, 4 girl is not covered. So, in such questions where all other subparts are covered, it is also enough in order to find this together is equivalent to finding the total number of ways of selecting the committee minus the number in which 4 girls are selected. If you do that, also you will be able to get the answer for this. So according to my opinion, we will be using this method so that your work becomes a little more simpler. Your working will be a little more simpler, right? And now how do we go about doing this? Total ways of selecting the committee is very easy. Yesterday I was keeping on telling, if you don't have any subparts, no headache, directly the committee can be chosen. 9 plus 4, 13 people, select 7. That's it. Total number of ways of selecting them is 13C7. How, from where you got all this? 9 has come because of 9 plus 4, 13 people we have as a choice, and 7 people we have to choose. So 13C7 is a total way of doing it. And for 4 girl case, we have to just borrow the number from here. You will get it. Once you subtract it, get the answer also. It becomes a little more easier to work out. So this is in nutshell the working for this problem. Now here and there, now we have to write those statements and do the problem. That we will do now. Okay, first part 1. Exactly 3 girls, that's a subpart. So we'll write here 3 girls have to be chosen, have to be selected from how many? From 4 girls. And so because you're selecting 3 girls, you have to select 4 boys, and so 4 boys have to be selected from how many boys? 9 boys. So number of ways of doing it. Doing it is 4C3, comma, and for this it is 9C4, and total number of ways of forming the committee. The simple, sweet, and brisk. The next is not going to be like that. Lots of work. Forming the committees. 4C3 into 9C4. Of course, we have to do the working. 4 factor 4, say n, c, n minus 1. I remember telling yesterday's n. So why do all the headache? 4 n, c, n minus 1 is n, and 9C4 is 9 factorial by 4 factorial into 5 factorial. N, c, r is n factorial by r factorial into n minus r factorial. So this is 4 into, writing this is like writing 5 factorial, 6, 7, 8, 9. 5 factorial, 4 we can write it as 2, 3, 4. 4 factorial we can write it as 2, 3, 4. Let this get cut. 6 get cut. So you have what? 9 8s are 72 into 7. 504. It's a favorite number, keeps coming here and there. And we have seen 504 coming many times. First subpart is done, right? Where we have exactly 3 girls. Now there is a second subpart where we have at least 3 girls. So in the second subpart, at least 3 girls. We have to consider cases. We have to consider cases with 3 girls and 4 girls. In case when 4 girls are to be chosen, are to be selected, I am wondering about the boys. 3 boys have to be selected from the 9 boys. So, number of ways of doing this. These together we'll write so that we don't have to write that step again. So we have 9C3 and 4C4. N, C, N. Should be 1. N factorial by 0 factorial. It's 1. So this is 1. 9C3 is 9 factorial. Do we have it? 9 factorial by 3 factorial into 6 factorial, or like 6 factorial, 7, 8, 9, 3 factorial is 2 into 3 into 6 factorial, which can cut, and 3 3s are 2 4s are 28 into 3. How much is that? Or 12 into 7, that's better. 12 into 7 is 84. Now this is just one case, okay. In just that case, okay. So to get the answer here, required number of ways of forming this committee. Too much of writing is there here. See, whenever we do in this particular this, you have to be careful that whenever we take up two cases, the case 1 and case 2 and case 3, they have to be added up. You have to have the answers and you have to add it up. So this is our case 1, this is our case 2. Case 1 answer is 504. So if you want, we can write this 4C3 into 9C4 plus 9C3 into 4C4. These two cases we have added up and we all have the answers. So 504 plus 84, which gives us 588 as the answer. Next is at most 3 girls. So at most 3 girls, that blah blah, you have to say that you have to consider cases where there is 0 girl, 1 girl, or it is like considering the total minus, yeah. Here we take up cases with 0, 1, 2, 3 girls. In order to get this number, we subtract 4 girls case from the total. Ways of forming the committee. Broadly, the committee of 7 is formed from 9 plus 4 equal to 13 people. So, total number of ways of forming the committee. It is 13C7, and mathematically it's 13 factorial, 7 factorial, 6 factorial, the difference. And when we write this, it is like 7 factorial into 8 into 9 into 10 into 11 into 12 into 13 divided by 7 factorial into 2 into 3 into 4 into 5 into 6. For 7 factorial, let's knock it off. Then we have, let's start from here. 6 2s are, 5 2s are, 4 2s are, 3 3s are, then one of the 2s. So what are we left with? 13 into 11, then multiply with all that. So whether we can have the 13 into 11, where I can borrow some place. 13 into 11. 11 3s are 33, 3 carry. 11 1s are 11, 40, 143. So 13 into 11 is over. Then 2 2s are 4. There is 2 2s are 4. 4 3s are 12 is there. So multiply by 12. 12 3s are 36, 3 carry. 48 and 3, it is 51 and 1 7. So it is 1716. Not got the answer, you have to subtract. Then only you will get the answer. So required number of ways of getting the committee. Therefore required number of ways of forming the committee. Forming the committee is the total minus the 4G case. That means it is 1716 minus the 4G is this 84. Let's see what comes. 6 minus 4, 2. Borrow. 11 minus, this is 6. 11 minus 8, 3. 6. 1, 6, 3, 2. So in these many cases, you have the girls with whatever conditions that they put. This is how we are able to get the girls up. So that is all about this video. We come with the next problems in the next video. Thank you.